or x is 28 after we add 1 to it, what can we say before we add 1 to x? Okay, x equals 30 or x equals 27. Right? Okay. So once again, we have the same restriction applied, except in the opposite way. Because we would not be in the then branch using the true path unless the condition is true. If the condition is true, then we know x has to be even. It has to be even in order to go to the true branch. Okay? Well, that means that x can be 30. It does not conflict with the condition of the conditional statement. But x being 27 conflicts with that condition. So we have to eliminate x equal to 27 as a possibility. Are we doing okay so far with this? Now this is something that we have to be careful because it has to do with the condition of the conditional statement. So that means if I merge these two paths up to the point where they are coming from the same origin, I can only say that x equals to 30 or x equals to 31. X equals 31 comes from the false branch, and x equals 30 comes from the true branch. Are we doing okay so far with this? Going backwards? Now, with a question like this, when we're moving backwards, you don't have to use the substitution, the inverse functions, and whatnot, even though that can be helpful. But you can just, and not doing this on a piece of paper, that means you cannot turn in something like this either. We don't have a scanner on each computer to scan. Yep.
I was just noticing on this, that false path in second, that would have never been taken to reach 28. And in our precondition up top.
Correct. Yep. But the reasoning that goes up, we cannot eliminate x can be 28 until we deal with the first conditional statement. In other words, if I just give you the second half of this question, if I just give you from line 35 to line 37, then x can be 28. But since I give you also the first conditional statement, that eliminated the possibility that x can be 27 initially and therefore become 28 later on. So you're correct. At some point we got rid of x can be 28 because of the restriction of x mod 2 has to be 0. Okay. So what remains in this case is we start with the precondition, which is x equals 30 or x equals 31, and then we move forward using the usual derivations and then come to the same conclusion. So what we'll do is we'll go ahead and do that part today. And this is just using a regular text file. Okay. So now we can say that we have a very strong suspicion that pre-32 is x equals 31 or x equals 30. Okay. And from that, we can derive what is pre-33. In other words, we know that we took the true branch of the conditional statement. What can we say about pre-33? Pre-33 is based on pre-32 because there are no operations happening between those two lines. So whatever was true on line 32 has to be true at the beginning of line 33. At the same time, we also know that x mod 2 has to be 0. That has to be true because otherwise we would not be taking the true branch anyway. Is that okay so far? Why I have a conjunction of pre-32 and the condition of the conditional statement. So once you expand this, it becomes x equals 31 or x equals 30, and x mod 2 has to be 0. And that simplifies to x equals to 30. Now, how do we do this? How can we do this simplification? Remember what we talked about with conjunction? If you look at it from the perspective of set theory, it is basically looking at the intersection of these two particular set of numbers. So in this case, one side has 2 points. Okay, one side has one point being 31, the other point is 30. X can be 30 or 31. The other side, on the other hand, have a whole bunch of numbers, okay? Because the other side is saying x mod 2 is 0. Okay, what kind of numbers are we looking at in order for the mod 2 to be exactly 0? All the even numbers, right? So the other side has 30, 28, 26, 32, 0, 2, negative 400, and so on and so forth. Okay? And as a conjunction means that we are overlapping the two and only find out which part is intersecting. In this case, the intersecting part is a single number, x equals to 30. Okay? Because 31 is outside of the intersection, 28 is outside of the intersection, and the only intersection in this case is 30. Is that making any sense? Okay. So as a result, we can simplify and just say that your pre-33 is just that x equals to 30. Then we can say the right-hand side of line 33 refers to the left-hand side, okay, because both sides have x in it. And then furthermore, the right-hand side of line 33, and this time I call f of x so that I can use an inverse function. F of x is x plus 1 as an inverse. The inverse function f prime of x is just x minus 1, because if you're adding 1, in order to undo the add 1, you can just subtract 1. In the test, you don't have to prove that one is the inverse of the other one. You just have to say that okay, here is the inverse function of the other one. So that means we can apply. Which rule should we apply? Should we apply the forget rule or the substitution rule? Substitution rule. Okay. So the substitution rule says the post condition of the same line is based on the precondition of that line. We change or we replace occurrences of the variable x in this case with the inverse function applied to x. And then you just have to expand everything. Pre-33 is simple. It is just x equals to 30. We replace occurrences of x with x minus 1, because x minus 1 is f prime of x. And that becomes x minus 1 equals to 30. If you do one more step of algebra, x equals to 31. And we do okay so far with this? Okay. The algebra in this case is just adding 1 on both sides. Adding 1 to negative 1 cancels it out. Adding 1 to 30 gives us 31. Okay, well, that's good. What is the other? Okay, what about post 34? What can I say about post 34? Well, I know one way to get to 34 is post 33. Okay. In other words, this is our post 33, and this is our post 34. It's one way to get there. But there's another way, because it is a merge in this case. So we have to look at the other way, which is a disjunction, because by the time we get to post 34, we would not have remembered which way we came from. So the other way is basically the negation of the condition itself. So you have to say it is not the case that x mod 2 equals to 0, because otherwise we would not have taken the else branch. And at the same time, pre-33 has to be true. Because when we take the else branch, whatever condition was true here will still have to be true at this point, because the else branch in this case has no operation whatsoever. But at the same time, you would not be taking the false branch unless the condition is false. And that's why we have to specify the negation of the conditional statement and the precondition of the entire conditional statement. And of course, in this case, you just have to expand it. Post 33 is just x equals to 31. The other side, you can simplify a little bit and say x mod 2 does not equal to 0. That's the negation over there. And then pre-33 is to say x equals to 31 or x equals to 30. And I need parentheses, just like that. Okay, let's take a look at this mess here and use a picture to see if we can simplify a little bit. Can I erase this part here? Okay. It's going to look almost exactly the same. One set in this case is just saying x equals to 31, which is one point, one element in a set. Okay, x is exactly 31. What about the other one? Oops, sorry, I take it back. Okay, if you take a look at this part here, x can be 31 or x can be 30. That means we have two dots. One dot represents 31, one dot represents 30. Okay, that is the right-hand side of the conjunction. What about the left-hand side of the conjunction? X mod 2 does not equal to 0. It means x is an odd number. Okay? What numbers are odd? 31 is odd, 29 is odd, 27 is odd, 33 is odd, and so on and so forth. So that means the right-hand side, the left-hand side of the conjunction, x mod 2 is different from 0, specifies all the odd numbers. Okay? So now we have a big bubble on the left-hand side because it is also representing 27, 29, 1, 3, -5, and so on. Okay? So we have one really, really big set of numbers on the left-hand side, and we have a relatively small set on the right-hand side. The conjunction means I want something that is common to both sides. And there's only one thing that is common to both sides. The 31 is the only one that is common to both sides. So that's why we can do the simplification here. And this entire thing simplifies to x is 31 or x equals to 31. Is that right? Yep. Which means x has to be 31. Are we doing okay so far? Okay. No? Okay, let me just point out in the big picture. Starting with the assumption that on line 32, x can be 31 or x can be 30. By the time we get to line 34, we only have one thing left. We know that x has to be 31 by the time we get to line 34. That's what it's saying. Is that okay? So knowing that, we can now continue on with line 35. The precondition of line 35 is the same as the postcondition of line 34. Why?
It's the next line following right after.
Because they are sequential. Okay, so you can just say because the statements are sequential. Okay, that's good. If I know that pre-35 is x equals to 31, can I say something about pre-36? Okay, what should that be?
X equals 31.
Okay, well, let's put it this way. We'll say that whatever was true before line 35 is still true. Okay, because if you look at the picture, the picture once again is very useful. Pre-35 is this here. Pre-36 is this here. I didn't have a chance to change anything. So whatever was true here has still to be true at this point. However, I also know that the condition has to be true because otherwise I would not be going for the then branch. Is that making any sense? Okay. So that means I have to say pre-36 is the same as pre-35, but we also know one thing on top of that. We know that x is greater than 30. Okay? And once you expand it, it becomes x equals 31 and x is greater than 30. And we can simplify this. Okay? So once again, we can simplify by looking at the intersection of these numbers. Okay? The left-hand side of this conjunction